It's a franc. So this integral looks like really tough, right? Because there's this product sign, and again there's this alternating negative 1 to the power n term. Also, there are trigonometric functions tan and sine. So it does look tough when you are looking at it for the first time, but it's actually pretty easy. So yeah, I just want you to not get afraid by the complexity of the integral that you might feel at the first uh, sight, right? So now let's try to see like what the product actually evaluates to, and then you will see that it's actually easy. I guess you know about the product notation. That means we will just evaluate this expression over here, this entire expression, at all the numbers from n equals to 0, n equals to 1, n equals to 2, n equals to 3 up to infinity, and then we'll just take product of each of them. So it will just be e to the power 8 n equals to 0. This will be just minus 1 to the power 0 is 1, and tan x to the power 0 is 1, right? Yeah, times e to the power, this is negative tan square x, right? Times again, this is again positive, and then 10 to the power 2n is now 2 times 2 is 4, right? And then 10 to the power 6x, right? And also there should be negative sign now, because now n is 3. So yeah, I guess you get it, right? Because this is 2 into 1, negative sign is there, 2 into 2, minus 1 to the power 2 is positive. So I guess you get the idea. We are just trying to evaluate this, and it goes on. So, and dx. So the thing is, integral from 0 to pi by 4 sine 2x of e to the power, this is 1 minus tan square x plus 10 to the power 4x minus 10 to the power 6x plus 10 to the power 8x. It goes on. So you might notice that it's actually a geometric sum, right, which goes on to infinity. Now if the symmetric sum has common ratio r greater than 1, then it would be a diverging sum, but if it has less than or equal less than 1, then it will become converging, right? So over here the domain of integration is between 0 to pi by 4. In this domain, when the theta is, let's say x in this case, when the x is in this domain, we know that tan x is just in between 0 to 1, right? And that's exactly what we want, because tan pi by 4 is 1, and tan is increasing between 0 to pi by 4, right? It's also increasing between pi by 4 to pi by 2. So yeah, we know that so that's why we know it will be just bounded in between 0 and 1. So we see that the modulus of tan x is definitely less than 1 when modulus of x is less than pi by 4, and that's the case over here. So that's why we can say that this has the common over here, this symmetric sequence, this actually has common ratio like minus tan square x, right? Because the every next term is multiplied by minus tan square x. And yeah, definitely the modulus of r is just the modulus of tan square x. And yeah, this is just like the modulus of tan x square. And yes, it's less than 1 square, which is 1, right? So since it's less than 1, we can use the formula for the geometric series. Let me just erase this out. We don't need this stuff. Right, we don't need all of this. Now this all the thing was just to make sure that our this r, which is negative of tan square x, this our common ratio, its modulus is just less than 1. Yeah, now if you have the case, I can use the formula that the sum is actually a by 1 minus r, where a is first term, r is common ratio. So this is 0 to pi by 4 sine 2x e to the power a by 1 minus r is negative tan square x, right? Now see how easy this has become. Now there's not a lot of things to do. Now you can easily solve it. Sine of 2x, and then e by, we know that 1 plus tan square x is just sec square x, right? So this is 0 to pi by 4 sine 2x e to the power 1 by sec square x dx. So this is 0 to pi by 4 sine 2x and then e to the power cos square x dx, right? Now if you just make a substitution that u is cos square x, you see that du is just 2 cos x minus sine x dx, and this is just minus sine 2x dx. So negative du is just sine 2x dx, right? So using this, you get now cos square of 0 is 1, cos square pi by 4 is just 1 by 2, and then now sine 2x dx is just negative du, and this is just e to the power u. Now you can use the negative sign to reflect the integral. So integral will go from half to 1 e to the power u du. This is just e to the power u going from half to 1, because the integral of e to the power u is just e to the power u, and that means it's e minus root e. And that's a nice answer, to be honest. So this was just like trying to evaluate the product, and if you could evaluate the product, trying to get the powers, and then if you could notice that there's a geometric sum with ratio less than 1, just use geometric sum formula and that's solved. So this was it. The answer was pretty good because it was e minus root e, the irrational answer. And I do hope you enjoyed the integral, and then now you might have got a lesson that you should not be afraid because it looks hard, it looks tough, because it could be simplified just as this one was. So that was it. Thanks for watching, and I look forward to seeing you in the upcoming videos too.